All right, so we have cost estimates for all of the competition projects that they had to develop as part of the competition. They had to do a comparison between what they considered traditional design and then what was their LID design costs. There was kind of I would say the trickiest part as far as, us going through the process as well is really when you're designing an LID site plan and you've got that and that's your site plan, then to have to go back and say, well, what would you have done traditionally? It's kind of hard to retroactively think that through and then try to put a cost estimate to it, but they did the best they could. So first, I wanted to go over some of the kind of standard things that you see, and they're going to be reoccurring throughout all these different cost estimates. So, what is traditional design? Again, it's getting that water off quickly and efficiently. You clear, cut, and grade. You put a curb and gutter in. You put a pipe system in. Lack of attention to conserving natural features, and usually the focus is more towards detention, which requires excavation, outfalls, and loss of space for development. Those are kind of the main costs affecting there. So, whereas you'll hear a lot of engineers talk about, oh, there's no cookie cutter design for one site, and we like to design each site from scratch. If you look at development over the past few decades, that really doesn't seem to be the case. You could go to probably almost any shopping center and you'll see the same practices put into place. You can go to any parking lots or any subdivision, and they all look pretty similar. So what we're really trying to do is actually make people put in a little more effort at the beginning to try to think things through and to really hold true to that statement that they say there is no cookie cutter solution, that you have to think about these processes. So what are the cost savings found with low impact development? The first two are kind of the main ones. You see a reduction in pipe size and a reduction in quantity. That provides a significant amount of cost savings when you're comparing traditional to LID sites. And then kind of the reduction in impervious area, it helps with runoff and volume and things like that, but it also provides a very large cost savings. If you're reducing your amount of paving, using alternative sidewalks, and reducing curb and gutter, there's a lot of savings to be had there. Reduction in tree removal and or replanting. You'll see in a couple of these scenarios, landscaping costs actually went down, and while that's kind of against what you would think would normally happen, that's it's kind of looking at tree ordinances and some of those requirements and thinking about your planting requirements in a different way. Increased land value, reduction in long-term maintenance effort, as opposed to inlets. The great things about some of these BMPs is, while they may take more effort the first 2 or 3 years, they become less maintenance over time. They become more sustainable, whereas your inlets and pipe systems and things like that, they're going to become more maintenance over time. They have a higher likelihood of failing and needing replacement. So, and then the last one is, effective site planning provides reduction in quantity, size of stormwater controls for treating runoff. While treating runoff might not be a focus right now, that's, by reducing your quantity, you're also reducing any detention requirements you might have as well. So it's not all cost decreases. Obviously, there's kind of a balancing act when you're looking at traditional and LID and what kind of LID site features you're going to put into your project. So there can be increases. The typical ones we find is sometimes there are landscaping of additional area, so that can cause increases. And then if you are constructing some of these LID features, there's increases in excavation, the cost of excavation, import of engineered soils, and there could be just increases in some of these construction bids purely because the construction industry isn't familiar with these practices yet. Those first two there with the additional excavation and import of engineered soil, obviously in this area we do have a lot of clay soils, there's a lot of C&D soils, but if you look at a map of the entire region, you'll actually see a surprising amount of B soils in this region. And so kind of back to that development process and studying your site, that's really where you want to, look at your site, look at your soil map, see if maybe there are locations where you do have more infiltrating soils. And if you place some of these features on top of there, then you can cut a large amount of the cost for these controls just by siting them in areas with more pervious soils. So the bottom three also kind of relate to BMP costs. Preliminary study usually involved to determine feasibility, design effort, and then some of the controls can be pretty costly. When you're talking about green roofs, you need to look at your loading capability of the roof structure, and then also with those permeable pavers, there's quite a bit of excavation that goes into those as well, making sure that the underlying layer can infiltrate quickly. So where we have the areas where there's cost savings and areas where there's cost increases, really the hardest thing to define with LID is some of these long-term and hard to quantify possible cost savings. They're things that don't really go into the bottom line of construction, but if you look at the life cycle of a project, which is really what sustainability is all about, then you'll see some of these additional savings or possible additional costs. So reduction in buildable area, that's probably one of the biggest cost effects that's a little harder to quantify for LID. You are promoting, more pervious area, and so therefore you kind of have to reduce your building footprint. So if you're reducing that buildable area, then there's a chance that you're reducing some of the revenue from that site. But all the rest are places where you can see savings over the length of a project. Higher property values. There's scores of studies out there that show that residential and commercial development in these kind of LID site plan locations have higher property values, improved aesthetics, more recreational opportunities, erosion mitigation and water quality impacts. Erosion is obviously a main concern in this region. We have lots of erosion problems in our downstream creeks, and really by slowing down that water, more so than detention, just reducing your time of concentration and slowing things down is how you're going to help prevent some of that erosion in the future. And then irrigation. This could go one of two ways. Either you plant native plants that require little to no irrigation, or with some of the traditional designs, you plant some of the maybe more typical, I wouldn't want to say prettier, but more typical plantings that do require irrigation throughout the life of the project. So now I'm going to go into some of these cost estimates for the competition. These were all received. I'll go over the ones from the winners. And again, these are conceptual cost estimates because none of these have been built yet. Hopefully, in the near future, we'll have some actual cost estimates on the South Lamar project. But for now, these are conceptual. I'll also go over the EPA cost estimates, where those were actually built projects. So we have some hard numbers on what the cost savings look like for those. So the Central Arlington Library, as Strickle Rollins presented, first place design for the urban redevelopment. As far as the cost estimates you see there, so the biggest differences are going to be in the great inlets, reducing the need for those, and then for the pipe sizes. You reduced quite a bit of the pipe size needs, and that had a large effect on the cost. Connection to existing inlets, and then down there at the bottom you see the miscellaneous landscape plantings. Yeah.
It was actually reversed, so it was increased for a long time.
Oh, okay. Is it right up there?
No, we were talking during the break, and I just wanted to point out we had a discrepancy in the spreadsheet I put together from their actual cost estimate. So they did have an increase in landscape, which is to be expected on when you're adding more landscape than typical. So originally it was a 17% cost savings. That changes it to about a 14% cost savings on the library.
Okay, so still a significant amount of cost savings between traditional and LID design. So the next one is Cedars West. That's the one we saw the video for that HAF and their team won that competition, that part of the competition for. Their cost estimate, you see there's a total 4% savings. When you get into these larger projects, it's kind of hard to get as big as savings, but a lot of their savings up in the top there is from the drainage requirements. That obviously that went down from 1.8 million to $500,000, so there's a very large savings to be had there. And then down at the bottom, you'll see where that savings is kind of eaten up is through best management practice. By putting in those bioswales and water harvesting systems, you know, that's an additional cost that wouldn't be there for traditional design. But even with that additional cost, there's still a 4% total savings on the project. Another interesting slide from the Cedars West presentation. This was put together by Fuad Jabber from Texas AgriLife, and it's just kind of an interesting look at the economic analysis of BMPs. It looks at, you know, for the effectiveness of the BMPs versus the cost, which BMPs are kind of the most economically feasible to put in there, and it compares bioretention, permeable pavement, and rainwater harvesting. So you see there pretty conclusively that bioretention is the most cost-effective BMP that was selected for this project. Usually you'll use permeable pavers or rainwater harvesting where you have site constraints or limitations where you can't implement some of those cheaper aspects like bioretention. The Northern Crossing project, that's the one Ben covered, that was out in Fort Worth. That one had actually an increase, a total increase of 7% between traditional and LID design. So that's just kind of showing that, you know, there are cases where you are going to see some increases, but again, this is just their construction costs. So it doesn't mean that in the long term that the LID solution still isn't the most economically feasible. It's just for the construction bottom line, it ended up having a 7% increase. Most of that is from, you know, the bottom layer there you see from best management practices, hardscapes, and miscellaneous landscaping. So South Lamar, the roadway project that Ben presented on and that Freese and Nichols was selected as the winner from the competition. We showed totals of 8% in savings. Again, I'm really interested to see how these numbers will flush out once we've actually constructed the project. But we see a lot of our savings in the traffic signaling as well as in, that was an increase. We see the savings in our drainage and the reducing the infrastructure, also in site preparation and landscaping. A lot of people are wondering how, you know, you could get a reduction in landscaping, and you know, talking to some of the people that worked on this project, that came from, you know, if you look at the City of Dallas's tree ordinance and the requirements of, you know, how often you have to space these trees out and the sizes of them. We didn't necessarily follow those requirements. What we did was take a more detailed look of where would these plantings be the most beneficial, places like the bioretention ponds where they would actually provide a water quality aspect to the design. So while we don't have as many large trees and things like that would traditionally be required as they are in the Dallas tree ordinance, we kind of took a smarter approach of where to put plants and, you know, what sizes of plants would best treat water quality rather than just, you know, putting a certain amount of trees spaced along the roadway. So for the EPA studies, these cost estimates Seattle. Some of the cost increases there you see are site preparation and then landscaping, 35 and 45%, but those were mitigated through some of the decreases in infrastructure, the reduction in street width and sidewalks, and then also some miscellaneous costs such as mobilization. There's a table that gives you kind of the full comparison. You'll see there, between conventional is about $860,000, and then the LID plan for it was about $650,000 for the cost savings of $217,000. The next one, Prairie Crossing subdivisions, the Illinois project. Kind of the biggest thing to point out on that one is, so you have reduced road width, you get 13% savings, stormwater management, 15% savings, decreased sidewalks, that's a very large one, that's 46%, and then reduced curb and gutter. What that gives you is a total of $1.4 million in savings that they found, which equals about $4,000 per lot. So, I mean, that's a very, very substantial cost savings on that project. The next one, the parking lot retrofits in Washington. This is where they use those rain gardens instead of underground vaults. You see for the City Hall project, the conventional vault costs of $27,000, rain gardens of $5,000, gives you a cost savings about $22,000 or 80%. So a very large, significant cost savings there. Park project, you get about $40,000 in cost savings using the rain gardens, so 76% in savings for that project. So we wanted to go over, if you were, kind of starting from scratch and trying to figure out how much some of these BMPs cost, we wanted to kind of give you some tools that have been developed for estimating these costs. The one that we show here is bioretention, just because that is the most typical BMP that's put into place, and because of that, there's a lot of information out there on how to estimate the cost for those. So the cost elements that normally go into bioretention, there's a number of things you have to think about: your excavation, grading, filter media, what kind you're going to use, your drainage pipe if necessary. If you're on C or D soils, you're going to have a under drain pipe, and then erosion control materials, landscaping, seeding, compost, mulch, and any concrete work. So kind of one of the most common one we see is this by the study done by Brown and Schuler in '97. This is the one that's used by EPA, and it's in most of the EPA reports for how to estimate the cost of bioretention. And this is done purely just through a volume of water treated by the facility. Pretty simple calculation, just 7.3 times that volume to the 0.99. And this gets to approximately $6.8 per cubic foot of water storage, to kind of simplify that a little bit. It should be noted that bioretention usually replaces an area that would have been landscaped in traditional design anyways. Most cities have landscaping requirements or parking lot island requirements, and so we're not talking about adding a whole lot more impervious area. We're talking about, we're talking about utilizing what you have to the fullest extent possible. So if you have those landscaped parking lot islands, then why not make them a bioretention area? So your cost in land use is definitely minimized there. And then bioretention may reduce the need for other BMPs that do require significant amounts of land. If you put enough of these in, you're going to decrease any detention or wet pond needs. And then land requirement is typically about 5% of a drainage area. That's to help you in some of those cost estimations. So another good source for estimating the cost of these facilities, the City of Omaha has a very thorough bioretention design manual that I would recommend you go look at. They measure their cost per square foot between $7 and $12 per square foot of bioretention to build. They do note that it could be as low as 4 or as high as 15, so it really depends on kind of your site and the requirements of that, if there's going to be an under drain and things like that. So cost measured by drainage area treated, then you can see another estimating tool is that there could be an average cost of about $11,000 per acre. So if you have a 2-acre drainage area, that's a $22,000 cost for the bioretention to treat that. Treatment using BMPs is often 6 to 7% of total cost of conventional infrastructure construction. Can be variable based on design parameters. So, what are the most significant costs? Where are you going to find most of your money in your bioretention is going to be in those modified or amended soil materials, excavating those materials out or excavating that soil out and putting in engineered soil is pretty expensive. That's why if you do get any B soils or heaven forbid A soils in this region, then I would definitely recommend utilizing those to put your bioretention on those sites. Also, the use of live plants instead of seeds. If you can, the plants serve a very practical function in bioretention. There's actually pollutant uptake that they are performing. So it's the more you can put live plants in there instead of seeds, the more effective your system is going to be earlier on. It's also going to reduce chances of some of your mulch or some of that filter media being washed away through erosion or things like that. So cost of maintenance. Maintenance is a typical concern that we hear on some of these BMPs, especially in bioretention, and not so much how it's going to be performed, although those are our big questions as well, but also what's the cost? If these are run by the city, how much is it going to cost me to maintain these features? And what we really see is, like Ben mentioned, the first 2 or 3 years are pretty intensive as far as maintenance costs goes. We usually see those being about 10% of your total construction cost for the first 2 or 3 years. After that, though, there's a significant drop. It really just comes to walking around and picking up the trash and cleaning things out maybe every few years, doing a air pressure through the system to clean out any sediments that have settled in there. And so we see annual maintenance costs drop to less than 5% of the original construction cost. So kind of to go through a little example here and see what a life cycle cost would be. If you assume you have a drainage area of about 2 acres, and you're assuming $11,000 per acre to treat runoff, 10% maintenance costs for the first 3 years, and then 3% for long-term maintenance. You see those total costs pulled out for a bioretention system, and then kind of a graph of what the life cycle cost looks like. Obviously, there's the big upfront cost of construction, and then the first 2 or 3 years of maintenance, and after that, it really flattens out. And I mean, really, when we're talking about maintenance of some of these BMPs, any stormwater infrastructure you put in is going to require maintenance. Inlets require maintenance, pipes require maintenance, detention ponds especially require maintenance. So whereas people can sometimes get concerned about, a common complaint we hear is, this bioretention pond is going to catch all the trash that comes off my site. Exactly. Yes, it is, and that's the point. We want to catch, any large trash or even, those smaller sediments and things like that are coming off your site. And while it may require, a little more hassle up front of walking around and cleaning out those systems after every rain event, really what you're preventing is, having to clean out your inlet box or having to spend money to clean out your pipe system, or then having to clean it out downstream in the channels where it's deposited, and then heaven forbid having to dredge any lakes or creeks or reservoirs that you have where all of this is outfalling to.